Hello viewers, welcome to Easy EEE online series. In this lesson, we are going to be talking about voltage divider rule, or you can simply call it VDR. Though from the beginning of this session, we have been talking about um, how to analyze and how to solve problems that has to do with series circuit. So in the last session or last topic, we also saw that in series connection, the resistors share a common current, but have different voltage drops across them. So now we will try to find out the exact magnitude of voltage drops in each resistor. So, and for this reason, we are going to be making use of what we known as a voltage divider rule. So before we continue, we are going to branch into some aspect of VDR and applications of VDR before we move further into the calculation aspect. First and foremost, let's talk about potentiometer because there's no how we're going to discuss voltage divider rule without talking about potentiometer because potentiometer is one of the most important application of a voltage divider rule. So according to um, Wikipedia, uh, we come up with all these things. So we have a potentiometer is an instrument for measuring an EMF, basically by balancing it against the potential difference produced by passing a known current through a known variable resistance. Also, it can also be regarded as a variable resistor with a third adjustable terminal. The potential at the third terminal can be adjusted to give any fraction of the potential across the ends of the resistor. And the last but not least, a potentiometer, another name we call it is a pot, POT, in uh, electricity circuit analysis term. So a pot is a three-terminal resistor with a sliding or rotating contact that forms an adjustable voltage divider. So you can see it on the screen as I'm explaining it. You know what you see what a potentiometer look like. If only two terminals are used, one hand and the wiper, it acts as a variable resistor or a rheostat. So what does this mean? It means a potentiometer can be used to a potentiometer is an example of a variable resistor, which means you can easily change the resistance or in it at any time to a desirable resistance you want. And at the same time, that is if you connect one hand to the wiper. So if you look at it, there are three terminals on it. So the one at the middle is the one that is connected to the wiper. Whereby when you are rotating it, it increases and decreases um the resistance in the resistor. So why it can also be used as a what as a voltage divider. So if it is it can when you adjust it, it can divide voltage in between resistors in a circuit. So now what are we saying this? Let's quickly break it down. So there's no how we are going to be talking about a VDR without talking about the port, because port gives us the perfect example of what we are looking for, of what we are looking at. So now, uh, because the VDR can be exhibited by using a port, which is the potentiometer. So we are going to look at it in two different ways by what we have here. They say the port is a three-terminal resistor with a sliding or rotating contact that forms an adjustable voltage divider. So now, what are we talking about here? So let's take for example, let's say we have a particular circuit here. Now in this circuit now we have a resistor with a resistance of 2 ohms and another resistor with a resistance of 7 ohm. So we want to divide this voltage from this voltage supply into this circuit. We want to divide it between these resistors. So what do? We make use of what we call voltage divider rule. So in what makes this pretty more easier is that in any calculation that has to do with the electric circuit, there's always an equation. So the equations make it feel so easier for us to assess and analyze whatever we want to do and get in a circuit. And by the time you take measure of it with your voltmeter or your ohmmeter, or any measuring apparatus, you are still going to arrive at the same answer. So let's take an example of what we have here. We are going to use the what we call the equation for the voltage divider rule, which says that um, Vx is equal to um, E multiplied by Rx over uh, RT. So which can also be Vt, this is T, Vt Rx over RT. So what do we mean? When we are talking of Vs here, let's quickly analyze. So we have our Vs to be desired voltage that we need, while Rs is the required resistance, while RT is the total resistance in the circuit, and last but not least, Vt is the total voltage. And E also can also serve as what, as our total voltage, or normally use E. So in this case now, let's say for example we are looking for the voltage that will drop across this particular resistor. Let's say R2. So now we are going to introduce so what we are looking for will be V2, because we need the voltage that will drop across R2. So it's going to be V equals our E, which is what, 12 volt. The voltage in supplied to the circuit is going to be 12 multiplied by the resistor, required resistor, which is 7. So everything over the total resistor. The total resistor is 2 plus 7, which is equal to 9. By the time we punch our calculator, we're going to get 9.33 volts. So, and of course, by the time we subtract it, we can easily get the value for the second one, which is the R1. So 9.33, we should punch our calculator. 9.33 minus 12 volts. So our V1 will definitely be 2.66, or approximately 2 point, 2.67 volts. So that is the first thing we are going to be looking at here. By this way, we say we are looking for what, the voltage that drops in each resistor of this circuit. So we normally use this particular equation. So that's the first part. So another thing that we can also look at is that we also need to know that VDR can also help us to search or determine a particular voltage in a resistor. Let's say for example now, this is a particular voltage that we drop in this circuit in the second resistor. So now what if I want it to be, perhaps I want another voltage to drop. Let's say I want something approximately 5 volts to drop at the R2. So at the R2, then I'm not going to apply this formula again. So in that case, I'm going to introduce another VDR equation. So since our, what do you call it, since R2 is what we are dealing with, I want a particular voltage to drop at R2. Let's say for example, I want approximately 5 volts to drop at R2. So we can have another circuit. Okay, let's quickly take a look at the equation. So in this case, the equation will be like our Rs, which is the required resistor, is going to be Ry, which is the second resistor, so times desired voltage out. So the voltage that we need to get at that particular resistor, Rx, so divided by uh, by the time we subtract the voltage in, which is the source, the voltage that enter into the circuit, from the voltage out, that's the one we need from the resistor. So that is what we are going to uh, apply. So this one, I said, if we need a particular voltage, if you need a particular voltage in a particular resistor, so we can determine, we can choose a voltage to. So that is the essence of VDR. VDR also help us to what, to determine the voltage we want to drop in a particular resistor. So how do we do this? We apply this formula. So now let's quickly take an example that we cover this equation. We are looking for a resistor that will give us 5 volts here. So I told you that this formula is used for in case you want to determine a particular voltage that you want to drop at this particular resistor. So you don't know the magnitude of resistance that will give you that particular 5 volt. So this is where this VDR pattern comes in. So what we are going to do is we are going to introduce uh, using the same circuit. We are going to introduce the formula. So our RS is the R2, which is the uh, circuit we are looking at, the resistor we are looking for, which is R2. The next thing is what RY, which is the first resistor, which is 2 ohms, times voltage out, which is the output that we want to drop at this point, which is 5 volt. So everything divided by the voltage source, which is V in, so which is going to be 12 minus 5. So that is V out. So by the time you do this, you're going to have 2 times 5, which is 10 divided by 7. So your answer is going to be 1.43 ohms. So at exactly 1.43 ohms, if you can try it, you can try with your voltmeter, you are going to get the same answer. So at exactly 1.43 ohm, you will be able to get 5 volts at this resistor. So what are we going to be using here? We're going to be using what we know as a pot, a potentiometer, or any variable resistor. So what we just need to do is to what? Is to adjust the amount of resistance here, adjust it to what we know as 1.43. So by the time you are doing your calculation, you are running what do you call it? You are transferring your power into this circuit. We are going to have 5 volts that is going to drop at this resistor. So that is it on the second part, which is to determine the a resistor that will give a particular voltage that you want in a circuit. So and that is one of the most very important application of VDR. So I think we are through with that. Now let's take some questions under it. So let's quickly take a look at this example. Use the VDR to determine the voltage drops across resistors R2 and R3 in the circuit below. So this is the circuit we have here. So this circuit we have the positive and negative terminal. This is the voltage supply into the circuit. So let's give it 60 volt. 60 volt. So the first resistor is the one is 10 kilo ohm, second one 20 kilo ohm we have here. So we have 10 kilo ohm, and so we have to use what VDR. So by using VDR, we are going to the first one we are looking for is R2. Definitely we are going to use what our E. So our E is going to be, which is the total volt or volt supply, and multiplied by the resistor the required resistor, which is R2 over RT. So what does it mean? So our E can also mean our VT, which is what R2 over um, R1 plus R2 plus R3. So which is still the same thing as what's our total voltage, which is the voltage supply, which is 60 times the resistor we are looking for, which is 20, all over um, R1 plus R2 plus R3, which that is uh, 10 plus 20 plus another uh, 10. So plus another 10. So by the time we punch our calculator, we're going to be having uh, 30 volts. So we can cross check, please. So another thing, we are going to calculate the R3 as well. If we're going to calculate R3 using the VDR as well, we are going to do what? We are going to uh, uh, use the same formula, which is the same equation, which is E, because of the voltage of what we are looking for, the resistor of what we are looking for, RT, which is the same thing as VT, which is the supply voltage, times the R3 over RT. So sorry, the RT can be R1 plus R2 plus R3. See the same thing. So if you substitute them, we are going to have a 60 multiplied by our R2, which is 10 over 10 plus 20 plus 10. So in this case, we push our calculator, we are going to get 15 volts, as simple as that. So that is the application of voltage divider rule in a circuit. So you can use to calculate the particular volt that drop in each resistor, of the circuit. And we have already, that is the first equation, and we've already told you the second equation, which means you can also, in case we want to determine a particular voltage that drop in each of the circuit, so we can manipulate it as well by using this equation as well, so that we can uh, we can know the amount of resistor we need to get the voltage we wanted. So, and to do that, we need a variable resistor or real star to do that, and most preferably we use potentiometer or pot to do that. So here is another example. We are to determine VBC, VBE, and VB in the circuit below. So now we are still going to use our VDR. So because it's the VDR that we normally use in the first instance to calculate the voltage that drop in each resistors in the circuit, in the series circuit. So now what are we going to do? So we need VBC. Uh, that's the first question here. Our VBC can also be regarded as our uh, BC, which is a VR2 as well. So which is going to be our what do you call it, E multiplied by our R2 over RT. So which is going to be our E, which is 120 volt, 120 volt, which is uh, multiplied by our R2, which is equivalent to what, 20 volt kilo ohm, divided by R1 plus R2 plus R3, which is 10 plus 20 uh, plus 20 plus 10. So that is what we have here all around. So which is going to give us, without wasting much of our time, uh, so we have had everything together. This is, let's punch our calculator. So we notice that we are having our answer to be 40 volt. So please, you can please cross check. You should get 40 volts. So in the next question, we have to look for VBE. So we don't want to waste our time. That is why we are trying to short this video. So to um, okay, VBE, VBE, VBE. What are the resistances that we have in our VBE? So B to E. So we have R2, we have R3, and we also have R4. Yes, from V to B to C. So that is VBE. So that those are the three resistances we have. So what are we going to do? We are going to have our the voltage in into R2 plus R3 plus R4, everything over the total resistance. So which is going to be 120 volt multiplied by 20 plus 20 plus 10, everything over 60 uh, kilo ohm. That is the total resistor we have here. So this is also kilo ohm as well. So by the time we do our calculation, we do this one, we have this one to cancel this one. That is um, 2. So by the time we add all this one together, this is a 50 times, so that is 100 volt. So that is what we are going to be having there. So the last but not the least, which is VB. Our VB, I think. So the last question, we are to calculate the voltage across. So as well as the third case we have here is uh, we are meant to look for VB. So yes, VB. So if you look at the whole circuit, oops, VB. Okay, VB uh, is an unknown in this equation and in this circuit. So the equation altogether, the circuit altogether, uh, we are having from V to C, B to C, which is B. We know that it is R2. Now from B now, there's not B is unknown. So the same thing that is applicable to uh, BE. So what we have, if you look at the general equation, which is Vx is equal to ERX over RT. So in this case, our our Vx is equal to VBE. If you look at it very well, our V is equal to VBE. So which means uh, VBE is still the same thing as what we have here, because if you take it, you take if you move from this B to the end point, the resistors you can see, which is that are under it as R2 plus R3 plus R4. So those are the resistors you can see under it. So those are the resistors you can see under it from B to the end. So it is unknown. Definitely our VB is unknown as well. So that is why we pick it as our VB. So definitely the value of our Vx, which is the VB, is equal to the same thing as our value of our VB. So I think that is was what we got in the first instance here, which is 100. Uh, yes, yes. Yeah, that is 100 volt, 100 volt. As simple as that. So you can take a look and you can cross check later. Post any comment, there's any complaint, you can reach through our reach us through our email or comment down below. So now let's continue. Before we round up, let's quickly look at the applications of the VDR. So we can quickly do recap on everything. So from the beginning we talk about the VD. So and potentiometer. We already know what potentiometer look like now. So and we can use it as a rheostat or a potentiometer itself, which means it can be used to to determine the voltage that drop across the circuit, and at the same time it can also be used to uh, to to determine a particular resistor that give the voltage we want in a circuit. So the symbols for variable resistance, I think we have discussed about it in one of our videos. So it's either it's in this form or in this form also. So you can adjust it after you have done your calculation. You notice that the resistor you have in that circuit, in that particular circuit you want for a particular voltage is not enough. You can quickly adjust. So whenever you see them in your circuit, you note that this is a variable resistor. So by the time you are using it in a potentiometer, so and you want to determine a particular voltage that drops in a resistor, so you can use this formula. So according to what we have in the that page, so use this formula, you get a particular resistor, and you notice that the resistor you already have in the circuit will not suffice you. So you quickly adjust. They are adjustable. You adjust them. So now that is all about variable resistor. So the VDR will allow you to divide the voltages between two resistors, and therefore allowing you to step down the voltage from a power supply to any of the voltages uh, that you required in a circuit. So and that is not that is not all. And from this we can see that the more resistance you introduce in a circuit, the more voltage that is used. So I think this can be seen in um, our electric motor. So we mostly use this in our electric motor. So we use a potentiometer or VDR in our electric motor, so that we can adjust the speed of the motor. So the way it rotates, we can adjust the speed, and also in the volume of our radio or transistor radios or TV set, in the volume you can see you can increase and reduce the volume. So we normally use VDR as well. So to determine the particular voltage and resistor we introduce. So which means the more resistance you introduce uh, to the voltage or to the sound or to the volume, so the more voltage you use to reduce and to perform the action. So it is used to reduce the speed in or to adjust speed in the electric motor, in our our transistor radios at home that we normally use. So we reduce volume, increase volume. We don't know that we are using what VDR and a lot of more electronic gadgets we normally use at home. Please like, You can click on the thumbs up button and also share so that you can enjoy much of our videos. uh, thank you very much for this lesson. So we shall see you in our next class. Bye bye.